Hello students, today we are going to talk about the topic which is work, energy and power. So in this topic we are going to cover the various things. So that is work done by a constant force, then work done by a variable force, energy, the different forms of your energy, let's say kinetic energy and potential energy. Then we will talk about the work energy theorem, the conservative and non-conservative forces, power and collision. So let's start with that. So before we let's see the basic thing. What is that dot product or scalar product of two vectors? So when I just consider the dot product of these two vectors, I know that a bar dot b bar, which is ab cos theta. So let's say for example, these are the two vectors which has been given, a bar and b bar. So what we have to do, you have to take the component of b along a, or even you can take the component of a along b to make sure that both are along the same direction. So angle between them is theta. So we can say then a bar dot b bar. So let's say the magnitude of a bar, that is a and taking the component of b along this a, so which is nothing but your b cos theta. So this is how we can just make sure that taking the dot product over here, so that will give you the value of your dot product of these two vectors over here. So that is your ab cos theta. Now the same thing, so let's say for example that I have shown over here. So ab cos theta, I can write it down from that diagram also. Now, so what is that work done? So for example, let's say in this picture, you can say that the horse is pulling a cart. Means obviously the horse is just applying some force to pull that cart. So we can say for this case that horse has done some work. He has applied some force, and because of force, there is a displacement of that cart. So this is how we can define the work done. So let's say again the work done by a force. So simple, we can say that for this particular case, it is the product of component of force in the direction of displacement. So whenever I just say that, so for example, even so when I apply the force on this, let's say block, and if the block is going to displace in the same direction, let's say this is one of the case over here. So then I can say, for example, the work has been done. The work has been done over here. So it is a product of component of force in the direction of displacement and the magnitude of this displacement. So obviously it is not necessary that I will always apply the force in this direction only. So the force might be a oblique one. So this work done, you can say that now that is a f cos theta into s. So that is again fs cos theta. So for example, if this is the displacement, that is a s, and this is a f. For this case particularly, you can say the value of theta is 0 over here. So let's say this is what we can say. The same thing, the work done by a parallel force. I'm applying the force in this direction. Because of this force, let's say the block slides through a certain distance s. So finally it came over here. So that means we have done some work. That force has done some work. So the work done, you can say now fs cos theta. So the value, you can say the direction of f and s, they are along the same. Yeah, so their direction is same. So you can say for this case, your theta is equals to 0. So the work done for this particular case, you can say it is nothing but fs over here. Similarly, it is not necessary that you always apply the force that is in the straight direction and the displacement also occur in the same direction. So the force might be oblique. So you just apply the force in this direction, but still you found that the block has been displaced through certain distance. So this is your f, and this one you can say that s. So in this case, what we have to do to find the value of that work done, take the component of force in the direction of displacement. So that is your f cos theta into s. So this is your work done, you can say that. So which is your fs cos theta over here. So that is your work done by a oblique force over here. Now there are few points regarding that work. So let's say the work is a scalar quantity. So definitely it is having the only magnitude. It doesn't have any direction. So let's say we are used to say that today I have done so much of work. Yeah, so but definitely it doesn't have any direction. So that means what we can say, it just having the magnitude. So today I have just done a lot of workout. Yeah, so today let's say I have 100 that push-ups and all those things. So definitely we can say that. So this is all about your work done, which is a scalar quantity over here. So the work can be positive, 0 or negative. So again you can say that, so that it might be positive, 0 or negative, that also we will see. So the negative work doesn't mean it is a vector quantity. Again, so definitely that is what we can say for this particular case. Again, the work done by friction is negative as the displacement is opposite to the friction. So that is nothing but your negative work done.